I'm Arun, with me Manish. So today we are going to talk about an introductory session of EDK II for server platforms. So before we get into the presentation or like the talk, let us introduce ourselves. So maybe Manish, you want to go first?
Yeah. So good evening all. So I'm Manish. Overall, if you see my experience, I started with the server manageability for storage servers. Then I had open source experience with working with OpenBMC. Then data center power management and circuit protection product development. So now I'm working at Lenovo ThinkSafe Steam Server as a firmware developer. Yeah, and my interest lies into power management, data center power management product and open source project. Yeah, I think Arun will introduce.
Yeah, myself, Arun Mahendran. So I'm also part of Lenovo, mostly working on firmware, so most of my exposure is on data center products, on servers and different server storage and PDUs and things like that. So I also have exposure on data science and AOps, and on recent times I have been looking into use cases and around sustainability and AOps use cases to help reduce carbon and energy efficiency and things like that. So that is one of my recent passion on what I drive. Yeah, so now let's get into the talk. So in the presentation, we have actually primarily two sections, like initially, so this is more on an introductory section to EDK, which is the boot phase of server, so or like even a host or like a laptop, so the initial sections of boot phase of server. So we have divided the sections into two, like primarily the introductory aspect of an EDK, where we need to cover the platform, the server platform, and even some of the basics of boot process and things like that. So I'll be covering in the initial section, and Manish will talk more on the EDK aspect of it. So now let's look at this diagram where, so a server is like, or I should say any platform which we could logically separate into two subsections. So one is called manageability section, and the second one we can say it is like the host or workload, where the workload runs. So the manageability section is more on monitoring and managing the server hardware or controlling the server hardware. So those aspects comes on the BMC or board management controller or manageability. And the host side of the host side systems, which mostly is part of the workload or the CPU where the actual workload runs. So now, when you look at how a server gets powered on, so the moment you plug a cable or you give power to a server, so the power gets directly supplied to the manageability section. So it is always running piece. So the manageability controller would be always running. In terms, it's called board management controller. That would be always running. But the host side is something that is controlled. Generally, you switch on the power, you get power to server using either a remote power or like a power button. So the moment you press power button, it does certain voltage level verification and things like that, and the BIOS gets starts booting. So and then once the BIOS boots, it does certain hardware initialization, and then further it loads the operating system. So that's how the overall high-level boot process would look like. And now let's try to understand how BIOS or BIOS is pictured, or how it is interfaced to a CPU or a server. So if you look at this diagram, it shows how a CPU is high-level blocks looks like. So it has core where the execution happens or the opcodes runs, and it has memory controllers, It has a storage controller, and you could also see something called SPI, or like, that is SPI controller, which is where the BIOS image gets interfaced. So that's the interface or the protocol that serial peripheral interface, that is where the BIOS image gets loaded through that interface. So BIOS generally sits on a ROM, and that gets loaded through this SPI interface. Yeah, now let's look at what I think this is basics, and so BIOS itself is like the acronyming, it says that it's basic input-output system. So basic functionality of BIOS is to initialize and configure the platform hardware, and also it helps operating system in many ways. So some of this very basic functionality of BIOS and its roles are like, one is the POST, which is a power on self-test, where it verifies some of the hardwares and the components of the platform itself, and make sure that it boots properly. So that's a very initial phase of the BIOS. And then also it helps to sequence the boot process in terms of what order you want to select the device on which you want to. And also it helps to set this boot sequence and things like that. And also it has certain configuration at hardware level, or like each subsection level you can configure, like you can configure storage controller, you could also configure certain network settings and things like that. So that is the configuration aspect of it. So now BIOS is something that is not most commonly now used. That is where now the UEFI and other new terminology comes. So there were challenges in terms of BIOS. So that's where people started thinking about new specification and standardization around that. So some of those challenges are listed here. So the basic nature of BIOS is more of like custom in nature. So it's not flexible to add new features, or like integrates a new hardware. If you want to support a new hardware, it is not flexible enough. So there are a lot of custom development happens in terms of each vendor. So, and also it lacks some of the boot security features. So which I'll be covering in the next slide. So, and also it has a very minimalistic user interface to configure. And also another challenge is its disk space. So BIOS uses something called master boot record, which limits its disk size to be around 2.2 TB. Yeah. Now, so now these challenges made industries and industry leaders to think in terms of like, how do we standardize this boot process and the initialization process. So that's where the next thing, which is UEFI, or Unified Extensible Firmware Interface, that gets derived. And so that's a forum where these boot specifications are defined. So the functionality of what BIOS provide, the same thing is also defined, similar with more advanced features is being defined by the UEFI forum. And so some of the main features that UEFI starts supporting is its advanced network capabilities, like it started supporting network boot, like Pixie boot, and it has a lot of network protocol supports in terms of DHCP configuration, and it also supports IPv4, IPv6 protocols. So, and also it has defined some security, boot security features, like root of trust and secure boot. So people use interchangeably these features. So that is being defined by UEFI specification. So the specification itself is evolved from the base specification that initially EFI 1.1 specification that Intel has published. And in 2006, the first UEFI specification got released, and further it also has HII, which is more of the user interaction or UI definition happened at 2007, and further secure boot and network boot, and then even virtualization got added later. So this is about its evolution and why this specification is being thought through, and why. And so to define or like to explain EDK better, so we need to understand the basics of why it is being evolved, and then why it is being came as an open standard and thing. So now under the UEFI specification, there are certain set of specifications that covers different areas of boot. So the primary part of it is the UEFI specification itself, which is the core, where it defines the platform firmware and operating system initialization. So and the second is ACPI, which is advanced configuration power interface, so which defines the power and thermal settings or between host, operating system and UEFI, so which helps to configure the power states and things like that. And UEFI shell specification, the next one, which is more of the definition of how command line interface has to be there in UEFI environment. Okay, now the platform initialization, which is more on the initialization part of the boot process, so which covers a little in-depth specifications of platform initialization part. So now let us look at how a UEFI boot process or boot flow looks like. So, they have in the specification they have defined it into multiple phases, and the first it's called sec or security phase, and the second it is called PI or pre-EFI initialization phase, and next is Dixie phase or driver execution phase, and then BDS, which is where the boot selection happens, and next it's the TSL phase where the operating system starts loading, and then finally it is the runtime environment where the OS runs totally. So if you can see that whole diagram, there are like power on, and then the platform initialization happened in the initial phases of UEFI, and then later the OS boots. So here we will little bit deep more on what each phase is responsible for. So the sec phase, which is the first boot stage, and where when the CPU gets power, so where the reset vector gets loaded, so that's when the sec phase starts, where it does initialization of certain temporary memory, because the memory will not be initialized in the very initial phase. So that's when it creates some temporary memory which is needed for further processes to run. So then, and also in this phase, all the security aspect, which is the sec phase function as the root of trust, which is the first chain or first verification stage of the BIOS or UEFI, where it verifies the firmware going forward. So that is where it is called as root of trust. And then it moves to the PI phase, where almost many of the initialization of the chip and memory initialization and DIMM training and things like that happens there. So this phase is where the pre-execution things, like whatever is needed for the next phase for a driver to run. So all the initialization needed for the Dixie phase is being done in this PI phase. So driver execution phase, now moving into the Dixie phase. So this is primarily most of the hardware or the platform initialization happen in this phase, where all the peripheral hardware gets initialized during this phase. So it has majorly 3 components, like we can say Dixie Foundation, where it starts certain services for dispatcher and for the driver itself. There are few core services that it starts, the foundation. And dispatcher takes care of loading the driver, so it dispatches the driver and whatever needed for that particular platform is being loaded by or initialized by that dispatcher. So the driver is the code that initializes the hardware itself. So basically it scans the devices and loads the driver needed for that platform. So, and then comes to the BDS or the boot device selection. This is where you see where the BIOS or the UEFI move into a stage where you select the devices so that you can boot into whichever OS you want. So that's the stage where the boot device selection happened. And TSL is the stage now the operating system starts loading, where the bootloader starts running. So that's where all the UEFI initializing code would not anymore run. So only runtime services would start running, remains there. So runtime services are the services that is needed when the host or the OS is running. So for example, some exception handlers and things like that is needed when the host is also running. Yeah, so yeah, I think boot flow is pretty much that. And then these are all some of the UEFI implementations. Yeah, primarily you could look at EDK II, which Manish would be covering, and others are like some of the embedded implementation of UEFI. And yeah, now moving to this SMBIOS and ACPI, these are all some, this is also a specification that I think ACPI we spoke before. So most of the UEFI development or developers would be using this interchangeably. So both defines the control and inventory of devices on the hardware or on the platform. So basically, SMBIOS is defined by the DMTF organization, and which mostly takes care or defines the inventory of the system, which is like the serial number, model number, and firmware version, things like that. And ACPI is defined by the UEFI org itself, and they takes care of the power control, like you using these definitions, you can control or define or control the states of the devices, like the power states and thermal states and things like that. Yeah, I think pretty much the initial stage is done now. Manish should talk about EDK.
Yeah, thanks, Arun. So as Arun covered about the functionality about the UEFI BIOS, so basically this functionality is important to understand the EDK. So now we will go through, so here mostly I'll cover like how this framework will be built based on the functionality. And then let's say somebody is like newbie or not, wanted to create some modules, or Arun explain about the driver. What are the basic minimum things he can look into and start doing that? So yeah, so if you see EDK is Extensible Firmware Development Kit. You can say it is a framework which is an open source implementation of UEFI. So whatever Arun mentioned about that, there are multiple boot phases, there are driver, dispatcher and all. So which is like previously proprietary by a different vendor, different server manufacturer or silicon manufacturer. Now this is like UEFI EDK II comes with the framework which is uniform across. It is modeled into some packages, and so yeah. So EDK was initially started in 2004, and so EDK was the first generation framework. So which is primarily focused on the Windows development or Windows systems. Then afterwards, EDK II got implemented, which is having more versatile and flexible features. So which has multiple OS support like Linux, Mac OS. Then it comes with the packages. So the all this, what you can say, let's say you have security related some functionality. So that comes in one package. You have, let's say, some power management related things. So it will come with different package. So they make it modularized, flexible, different compiler supports and all. So this is just history of EDK or EDK II, I would say. Then if you see, this is the directory structure. So TNA Core, it's a community and which has different repositories. So EDK II is the one of the repository. Other supporting repository, like Arun mentioned about the UEFI shell. So generally BIOS or UEFI doesn't have shell, like you have Linux, you have bash shell which is available. So bash is already a program where you are running all the commands and all, but UEFI doesn't have something. So you need to have UEFI shell, and then if you want to run some, like let's say UEFI specific program and also, or some test cases, or let's say UEFI wants to talk to manageability control like BMC-based bed management controllers. There are Redfish clients, so which is manageability interface. So that kind of some projects are also included in TNA Core, which is supporting for EDK II. And if you see right hand side, which is like folder structure, which I was explaining about, there are like functionality wise they have divided a folder. So we will explore more further what this folder looks like and what it means and what it has inside. So now we will maybe start with minimum or shortest things in the EDK, which is a module. This is similar like Linux module. Only thing is like it has, it is very, it is meant to have one single functionality, and so it will has one file called as INF file, which is a metadata file. So you mentioned, if you see below, this is like that INF file, how it looks like. So it has version, then base name is like what is the name of that particular driver, then what is the so basically driver, I would say, like the module, what is the module type. So there are different phases, there are different type of drivers. So pre-EFI, DXC, and then boot device select. So different phases, you can specify different driver. Then entry point function is like entry point function particular to that particular module. And module, if you see, can have any, so it will be common to all the phases, or it will be specific to all the boot phases, or it can be UEFI shell application, or it can be a library. So module is an one entity which can have all these things. So now as we talk about the library, we will further see what is the library. This is also very similar like C library. Only thing is like as there are multiple booting phases, so we need to specify this library where it is being shared, which phases it's being shared, or which phases it supports. And or let's say, for example, you have debug library to debug that UEFI code. So let's say security phase, it doesn't require to have any debug logs or no code. But PI, DXC, and BDS, so it will output to the serial. Or you might have heard about the post code, like power and self test, and it output to the port 80. So port 80 is not any physical port or any web socket. It is just an terminology, like it will output to the post power and self test code will be output to that serial console. Yeah. So now we'll talk about, I think we will go back to this image, and if you see, these are all folders, which is actually as in package. So if you see crypto, then there are emulative package. You can create an emulator and then see how things are working, or if you don't have such team on platform, so if you want to try and find it out. So these are the package, and each package will have different modules. It may be library, applications, or different kind of drivers. So package generally has two files. One is the declaration file, which has which will tell about the dependency of the package, what are the library classes it is required to have, and certain components and structures. Then there is a description file, which is mostly on the platform specific, like which platform this package is about, then build options, what model inclusion and removal, all kind of things. So this is more on the platform configuration and then build options. So now if you see, if you want to build a single package, so let's say you created something, sample package, let's say, and you want to build a package. So what is required? So first is like you need to have description file, declaration file, which has all the necessary things like libraries, dependency and all. Then what platform you are doing, you need description file. And then let's say you have 4 models inside that. So each model will have one metadata file, or which is like what you can say dependency, or what are the things required. You can say in a way like make file extension of that. So you can combine all these things and you can create a package, build it, and then maybe if you don't have system, you can try an emulator and then run it, and you are ready to go to play with your package. So now, like one important thing we are talking about, like there are 2 models and you want to talk about, each models talk to each other. So then platform configuration database will come into the picture. So this is not something about database. You can say that this is kind of global parameterization. Only difference is like each model will have one token or a specific global ID. So let's say these parameters will be created for per modules, and that can be shared per modules, and then using that you can talk to other models like that. So this is again runtime also you can change this platform configuration database, and then let's say some runtime you need to, based on some event, you need to add some logs or put into some UEFI shells and all. So that can be achieved using this parameterized platform configuration database. It generally used to set up UEFI setup option. If you see the blue screen comes and there are multiple options, you can have you can change that using that this PCDs, also serial number you can store, product data, vital product data means generally if we have field replaceable units, or that data we can, or platform component data we can store there. So yeah, before moving to benefits of EDK, as I explained, like so if you want to getting started, maybe you start with model, see how model works, then you create some library, let's say debug library, add some debug prints, then put all this, or you create another sample model, put all this thing into package, add necessary dependency. Let's say you want to add which platform which platform you wanted to try this, add that platform configuration, build it, and then you will have that final package available with necessary drivers or models. Now, if we see like what are the benefits of EDK, as if you see UEFI is like having so many specifications, so many standards, so it is difficult to cope up with server manufacturer or ODMs to get that things and integrate it still. With EDK II, it's helpful, like it is already available, community driven, broader participation from firmware placement, which will help to reduce the final timeline for the product. Also, it is now operating system agnostic, so multiple OS it has supports, multiple tool chain it's supporting. Then as I mentioned about it, it's package based design, so you can let's say suppose you created a package or some driver, you can have UEFI shell and you can easily remove that package and add or insert that package runtime. So then code anyway definitely reusable. Whosoever contributed to this kind of driver, we can easily take that and then reuse that. And stable and reliable frameworks. So it's been since I think 2004 it's working. It's having so many contribution, and then it is following new standards, also maintaining previous standards. Yeah. So finally, if you want to get involved, TNA Core EDK is the repository. You will see all the packages you can go into, then you will see all the modules or driver. You can see that what are the it specified, like INF file, description file. Maybe if you want to start something like don't have platform, you can go ahead and try emulator package, and then you can, with your system, you can create some library or create some module, put some debug print. It will be shown to emulator. Then if you want to see, there are already well defined and documented guideline how to contribute, and there are so many trainings available. If you want to further digger and understand EDK II with more depth manner, finally it's done writer guide. So far, it is like for today we have this thing. Thank you. We can take any questions if you have.
I think we took around, I think it's over 10 minutes more, so.
Just wanted to know if this would be compatible with U-boot for embedded systems?
So not every, U-boot is primarily for embedded system, right? So it is minimal in terms of the availability. So some of the features, like some of the parts like secure boot and things like that are supported, not fully.
Okay, but I could still use EDK to compile a UEFI firmware that could be booted by U-boot?
Maybe actually if you see, generally if you see embedded Linux doesn't have BIOS and also, so if you see, maybe Arun explained about here. So if you see, U-boot will follow UEFI specification. Instead we can say that, so it will follow UEFI specification, but whatever, let's say, it's not the same phases like BIOS it is looking for, because embedded Linux, we not having BIOS, we have every memory constraint and all kind of things.
Right.
But if you see, like starting from that security phase, like so all these things they are following, and if you see, it will have different specification altogether.
Right.
So not which is like, if you see right now we are talking about the server and UEFI, which is not similar like embedded Linux.
Yeah, ACP and all of that would not be applicable.
Correct. Okay.
So my question is a bit separate from EDK. So in major Linux distributions, only 2 distributions, Fedora and Ubuntu, support secure boot. What are the challenges for distribution developers to include, to be compatible with secure boot in general?
Could you repeat that question?
Only 2 distributions support secure boot, are secure boot compatible.
Yeah.
Ubuntu and Fedora. So what are the challenges for distribution developers to make their distros compatible with it?
So the secure boot itself, it starts from the platform verification, right? So, and then it comes to verify the firmware, and then further it verifies whole of the operating system chain as well. So the thing is that the implementation aspect needs to be taken care by the verification of each of the stages needs to be handled by operating system vendors. So that needs to be handled basically.
Thank you.
I have one quick question here. So whatever you guys have explained, those are very good for the basic knowledge of the EFI or the EDK II. So this complete content belongs to the x86 architecture only. So did you guys get a chance, if we change it from x86 to ARM, so how the process will be different? It will remain same or there will be some changes?
I think we did not get fully explore about other than x86 architecture, because now that's how it has evolved. But what we believe, like there are some, so if you see common code of EDK II, let's say so I think silicon vendors, so generally let's say consider x86 architecture. So silicon related packages, so Intel will provide, and this common code, let's say server manufacturer will take and then utilize further to develop the EDK. So what we believe is like similar, like let's say only that silicon specific driver is getting changed. So with that x86 driver, specific drivers are there, maybe we can replace with ARM architecture or ARM vendor specific driver. I think that should work. So we did not get chance to, maybe we will explore that further. Yeah.
Okay, thank you. One more quick question. It's basically from your second slide where you have explained about that BMC, baseboard management controller. So is it before EDK2 or after EDK2? How actually it works with this one?
When you say before EDK2, after EDK2, in
Like
the
it means if you say about the UEFI specification, UEFI we have a ROM code for it, okay?
Okay.
So BMC, it will start booting before UEFI or the parallel with the UEFI? How it goes?
So BMC is like a parallel thing which runs, it's a microcontroller runs on the server. So it always runs, most of the case, So it always runs. When the server is plugged in with power, so it always be running and monitoring. So when that's where in this, I think in the,
First slide.
Yeah. So here you see, right? So it is being logically split into two separate sections. So BMC is a separate microcontroller, I should say, board management controller. So that it's not even part of the host. It's a separate controller which runs on the system. So that even if the server is not powered on, that runs.
Okay, yeah, thank you.
Yeah.
So I had a question, so I'm not very sure if this is the right question or I'm asking the question right. So you were talking about the server CPUs, right?
Yeah.
So I'm just trying to understand with Intel SGX, if I have the Intel SGX server, okay. So it has some firmware where it initializes cryptographic key materials. Is that part of the boot process or what is it? I'm trying to understand. I don't know.
So
Intel SGX.
Okay. Secure guard, you are talking about Intel SGX means secure guard extension you are talking
So I think I can explain on this part. So basically this is a configuration part, the secure boot guard extension which you are talking about. So it depends on the user basically and it dependent on the TPM, trusted platform module. I hope I'm audible to you, right?
Yeah.
So I'm not aware of this SGX thing, but so generally when the secure boot part of it, right? So or like the root of trust. So the first trust or the root is most of the cases it's a hardware trusting. So then comes the next phase, which is the firmware, which is BIOS itself, right? So in most of the platform there will be a hardware root of trust, and then that is the first thing which kicks in when the I think, is that the...
Yeah, probably question? That is the answer.
Yeah, so in most of the cases, in any server platform, there will be a hardware root of trust, which would be the first component which kicks in when the power is being supplied. And then that verifies some of this BMC firmware also, and also the UEFI itself. And then further from there, the UEFI gets the reset in many cases. In most of the server vendors, that's how they initialize it, starts.
Okay, thanks.
Okay, then probably if there are no questions, maybe.
Any last minute question? Okay, then maybe
Thank you.
We'll find up. Thank you.